right, good morning everybody and welcome to another exciting edition of the National Center for Computational Toxicology's Communities of Practice. My name is Sammy Hamp. I'm a student services contractor. Today we will be hearing from Dr. Tony Williams and Dr. Katie Paul-Friedman about the CompTox Chemicals Dashboard v3 and InVitroDB v3.1 respectively. Before we start, I would just like to ask everyone to please mute their lines. You can do that by hitting #6. If you have any issues with the audio, please let me know in the chat, and I will try my best to get those resolved for you. And with that, I'll hand it over to Dr. Williams.
Thank you very much, Sammy. So good morning to everybody, wherever you are. I hope people are aware of the chemicals dashboard at this point. I've just recently returned from a trip, and it appears that still the message is only starting to spread to some regions. But we've been around now for approaching 3 years with the dashboard. The latest release included a fairly significant surge in the number of chemicals we're surfacing on the dashboard. And from August until December of last year, we were working hard to integrate InVitroDB version 3.1 and all of the assays, associated data, and new functionality to support that. That's the review we're going to give this morning. This is not going to be a how to use the dashboard per se, literally some screenshots and some details about what we were able to squeeze in. So 110,000 chemicals added in that period between August and December. We specifically were working hard to migrate as many of the chemicals from the ACTA system that Richard Judson has been running for a number of years. We were able to map up and integrate those data in. We also have another set of tens of thousands of chemicals that we have not yet made public because we're still doing some curation work on those. So we now have 875,000 chemical substances. To clarify, that does not mean structures only, because we are also dealing with a lot of UVCV chemicals, polymers, substances that you can't really define, things like olive oil, etc. So that's been quite a significant expansion. We've also started to add in minerals related to asbestos, things like this. The data also included InVitroDB v3.1, which has had a lot of rework over the past couple of years, a lot of data expansion. There are updated assay descriptions that came from working with Keith Hauk and Anita in the center here. Richard Judson has been working hard to expand, enhance, and curate the ToxFile database. So we're already on version 7 of data, and there's been a significant cleanup to some of the early data that was released. We released it early on as a beta. That is the way we do things on the dashboard. We commonly release beta modules for people to get an early look at what we're doing, and then finally give it the sign-off, if you like. We also have new opera predictions. I'm sure you're aware of the opera PhysChem fate and transport models that we have been building. One of our colleagues, Kamel Mansouri, who was postdocing here, has led that charge. Fortunately, he is still maintaining those, but he is actually not with us here at the EPA any longer. He's still local, still working on opera, still pushing out new releases. So we did some work to harvest new data, integrate them, and enhance the models. There's some user interface elements that we have worked on. There has actually been a fairly significant redesign of the website in terms of the underlying software and interface elements that we've used. Some of that was for our convenience, but as users you will see enhanced tables across the application. There was a rework of multiple chemical results. So this is specifically to serve searches such as search on a substring and see 1,000 chemicals, search on mass formula. We've made this multiple results page a lot more facile to work with, we hope. We've also integrated the ability to look at all AEIDs in the InVitroDB database. Early on in the past releases, we only had the EDSP21 assays. That was our first phase because we were migrating over the EDSP21 dashboard into the chemicals dashboard. This path through, we also enhanced that to include all of the ToxCast assays, Tox21. So you can now review the concentration response plots for all of the AEIDs. We've also enhanced some of the batch search capabilities. That's a lot of text, so let's dive into some of the visualization of that. There has always been the ability to have QC notes, quality control notes, inside our chemical registration system that we have been building on for almost 5 years now. So when chemicals are getting registered on our side, these QC notes would be added in to help us inside the center understand a little more about the chemical. And it became fairly clear that some of this was very, very useful information to make public, so we've added in the QC notes. When you come to a chemical, if you navigate to the bottom, there is a QC notes panel, accordion. Most of our chemicals, honestly, have nothing special to say about them, but some of them are quite detailed. So in this case, this is toxaphene, which has no explicit chemical structure, but the notes are quite distinct. And I'll just read a little bit of it. It's a complex but reproducible mixture of 175 distinct C10 chloro compounds, etc., etc. Lots of detailed information. I'll show you a couple more. Antimycin A is a mixture of 4 specific antimycins, safflower oil, etc., etc. So this type of information is there for certain chemicals. It's the lowest, as I said, the lower accordion to just underneath the chemical structure. There's been work going on with NIEHS and Kamel Mansouri to build pKa prediction models. These are now available in Opera. They can be downloaded from GitHub. We have integrated in the experimental data that was used to build the prediction models, but we had a bit of a blip in the agency around January where we were furloughed, so we did not have time, unfortunately, to get all of the predictions done, all of the data registered. So that is it in our backlist of things to do for the next release. But we have the experimental data in and the predictions done, but not yet visible. So you will see this under the Properties tab. Sometimes you make a decision with a piece of functionality that does not go down too well with the community. So in the last release, we had this piece of functionality where you hovered over a structure and it would suddenly control the browser window and it would pop up and all you could see was this large zoomed in structure. We got a lot of feedback very quickly that was not working for many people, so we did a slight update, removed that functionality, but we still believe that zooming in on a chemical is useful, so we've added this structure thumbnail capability. Bisphenol A, it's pretty irrelevant, but if you're looking at complex alkyl toxins like brevetoxin or paleotoxin, these are enormous complex structures with stereochemistry. This functionality to zoom in is very useful. Anytime you see a chemical on the screen, top right-hand corner, you're going to see this little magnification tool. This is the multiple results page. This is the results that come from doing a similarity, going to the similar compounds subtab. So for every chemical structure, we are already launching a similarity search in the background to a Tanimoto threshold of 0.8. We're well aware of the fact that people want to be able to adjust that. They want to go to a lower threshold, etc. Future functionality we will introduce. But in this case, what you're seeing is the right in the middle of the screen there, 390 chemicals have been returned. We're looking at the first row. We are sorting here based on similarity, so you should be able to see across the top blue bar, we have the ability to select all, download this set of 390 chemicals into an Excel file, a CSV file, comma separated value, tab separated value, an SD file. From here you can send to the batch search if you wish. So if you, out of these 390 chemicals, if you want to select a subset of them and send them to batch search to continue your queries, you can do that. And you can also sort by any of the criteria that we have. This one is similarity, but you could also have it by number of assays, active hit calls in ToxCast. As a percentage, you could sort based on number of products in CPDAT, etc., etc. On the right-hand side, you can see hide chemicals that are, and then that is a drop-down that allows you to hide isotopically labeled compounds. You can see in the top 5 here, every one of those is isotopically labeled. We have C13 labeling, deuterium labeling, and you might not be interested in that. You're not going to care so much about these isotopically labeled compounds. So you would hide chemicals that are select isotopically labeled. You may be interested in excluding all multi-component systems, so all salts, anything with more than one component. So you would also hide chemicals that are multi-component. So this is a new view of that. And on the right-hand side also is a filter. So you can start typing in the name or the CAS number. So type in conazole, for example, and it will show all conazoles that are in this subset. To the far right-hand side, again, is a little button that is switching you from the tile view, this is a structure tile view, to a table view. This is how you would select what you want to display in the tiles. So if you notice in this particular view, we have DTXS ID under the structure, CAS number, and the ToxCast assay count. Names cannot be excluded because that's the hyperlink that takes you to the full record, but you can change what is displayed in those tiles. You would exclude the ones you've already selected and then just use the shift key to select the 3 that you want to display. And we've added some visual cues now for loading large lists of chemicals. It would be ideal if when you navigate to a list of 20,000 chemicals that it loads in a fraction of a second. That is not the way that it works. So it does take a little bit of time. We're actually actively working on speeding this up, but in this case it is showing you that it's 2,000 of 21,000 chemicals have been loaded. There is a specific reason for putting this visual cue in, and that is the fact that if you wanted to send to the batch search to harvest more information from all the other databases, and you pass it over before the full list is loaded, in this case, if you sent to batch search, you'd only get the first 2,000. And we noticed that some of our colleagues were sending the lists around to other parts of the application before full list loading. So please wait for the list to fully load if you want to pursue other searches. And then bottom right-hand corner, loading of large lists retains ordering. So it used to be that we would load the entire list, and that list, as it loaded, was reordering based on one of the internal identifiers we had. This is quite annoying because you were trying to focus in on the set of chemicals that was already depicted on the screen. So all we've done now is, as it loads, we retain that ordering. Then you can sort once it's fully loaded. Batch search, working with mass spectrometry colleagues from NERL especially, but also across the world at this point. Because of the work we did with the MS-ready form of the chemical structures and the QSAR-ready form that we use for our QSAR model predictions, we are generating DSS toxic compound IDs. These are the structure IDs themselves, not the substance IDs. And because a lot of these compound IDs, DTX, CIDs, are moving around in spreadsheets, we recognize that people would actually like to take a list of those identifiers, not just the substance identifiers, the DTXS IDs, but the compound IDs, and look up a set of data for those too. So we've added that capability as a search input. And then we've added new functionality on the search outputs. So I showed you at the beginning that we have QC notes now for many of these chemicals. So if they're there, there's no reason we wouldn't want you to have access to them in the download files, so you can include that. And then we've also added a couple of enhanced data sheets, and I will show you what they look like. So inside the database now, we are creating relationships between parent chemicals and what we call predecessor or successor molecules. And the example of a parent to successor relationship would be a parent compound that has mappings to metabolites or photodegradation products, et cetera, et cetera. So these relationships are created inside the database, inside our chemical registration system, and then we can pass them out in this extended data sheet. An extended data sheet is a secondary Excel spreadsheet that you would download into Excel with from an initial query. So if you input a set of 1,000 CAS numbers and you requested formula mass, assay count, PubMed article count, that would put that into the first worksheet. The relationship mappings here would go into the second worksheet. If you also wanted to add associated ToxCast assays, that's at the bottom of this list here, that would add into a third sheet. So these enhanced data sheets are all delivered simultaneously, but in separate worksheets. As usual, we've added informational icons on the dashboard so that if related substance relationships doesn't make sense to you, it's hard to give a full explanation in a couple of words, hover over that informational icon and it is a basic level of description. Moving into some of the more exciting work that we've done for this release, a lot of that was basic functionality delivered to extend what we already have. A lot of our focus went into the bioactivity data. So as I said, we released initially only the EDSP21 assays that were associated with InVitroDB version 2. A lot of data has been generated since that release. The subset of assays associated with EDSP21 has grown. There's been a lot of assays being generated that you never had access to previously, and more chemicals have been run through. So under the bioactivity subtab, now on the left-hand side for a chemical, if there are data available, you will see these active subtabs. We're going to walk through each of these. There are enhanced tables for viewing, so you can see more information associated with the assay. The PubChem data widget is still in place. We have not changed that. And there's a subset of what we're calling the Toxicast models added. The data has also been updated and reworked. This is the table. So when you come to the Toxicast summary, you will see the rich visualization tool that shows you each of the individual assays with the active hit calls clustered according to target families. That's been there now for a couple of releases. This is the table view, and you can see that you can choose what columns you wish to have shown in the table. In this case, I've deselected some of them. This is cookie-based, so if you choose a particular view of the table that you would always want to show up for your view, you don't really care about, for example, the stock concentration or the gene name, you may choose to switch those off. All you would do is do that, and forevermore, when you reload your browser, unless you clear your cookies, and that's what you will be seeing. This is a much richer view of the data at this point. Of course, we've retained the links to the assay descriptions. That's the column adjacent to the modal. We have seeker paths, download files, and then links to the gene name and the AOP. All of these are hyperlinks out to the associated database. The work that was done to add a lot more details to the assay annotations has really paid off. So there will be many examples historically in the previous release where you would see no associated target family, you would see no description. This is an example from the last release, and that has been filled by adding a lot of data. So a lot of hard work gone on here to expand on this. And Katie, I think, will provide you a little more context around how this is going to serve and be of value. The compara work that has been going on between Richard Judson, Kamel Mansouri, and a large group of international collaborators has resulted in the compara models. Those have actually been integrated at this point. So those are viewed, and again, in terms of details about how the models were built, what the purpose of the research was, hovering over those informational icons to the left of the model name, you can actually see the links to the data sets. You can see the links to the publications, just like this. In this case, the compara publication is not yet published, but the project itself is living on ResearchGate, so you'll be able to link out to there and see PowerPoint presentations and things like that. The previous release, an EDSP subset, we would be showing all bioactivity curves associated with a particular assay. And in the earlier version of the EDSP21 dashboard, we had the ability to display and flag only the representative samples. So we added that functionality directly into this release of the dashboard. So in this case, I believe we're looking at bisphenol A. Yes, looking at bisphenol A. Without the filter of representative samples, there are 80 charts displayed just for this assay set, and now with the representative samples, You can see on the right-hand side, I hope, number of charts is 28. So that's the difference. You can, of course, return all samples and see all bioactivity curves by deselecting representative samples. In addition, you can see at the top panel from the previous release for bisphenol A, there was a subset of assays that has grown now in the latest update to include all of the steroidogenesis assays and also additional thyroid assays. I think Katie will probably touch on this also in a little more detail. The Toxicast 21 tab. So in this case, I was selecting the EDSP subtab. There is now, again, on the left-hand side, Toxicast 21. This now brings all assays up that are associated with all of our vendors. We've done the clustering based on vendor directly, and what you can see is when I've selected active at the top of the red box, all I want to do is display the bioactivity curves associated with all assays that have active hit calls. So by selecting that, out of the CTOX list, 2 of the 24 selected, 24 assays in total from this vendor, 2 of them have active hit calls. Selecting the accordion itself will open up that entire list. You will see the details of each of the assays. You'll be able to drill down into the modal to figure out, to see how everything was measured, whether there is associated literature, etc. By selecting active, we have 136 that have been selected. The number of charts on the right-hand side, you can see the top bioactivity curve here shown. And to the right-hand side, there is a blue button with a tile view that is going to show you a tile view of those particular bioactivity plots. So you have them all easily viewable on without too much scrolling. Because there's so much work being put into the InVitro database in terms of annotation and adding of gene annotations, for now for the assays that we have included, you can see associated genes. There's not only one gene associated. You can get a whole set of genes associated. And when you hover on the right-hand side, you see 3 genes. When you hover over there, it will list a particular set for you. This is the view I was telling you about, where you have a tile view now of the individual bioactivity plots all displayed. And again, you can now filter here. So at the top left-hand corner, under assay selection, if you want to filter by a specific gene, then you would simply type that in, and it would filter your set down. So the filtering is now available on many tables, many of the views of the data that we have. We've done a lot of work to add to the list of chemicals and list of assays also. So the chemical list page was rebuilt, so it's easier to navigate. It has filtering built on it now. We've added a number of lists. We've also added these prefixes to the list names so that they cluster a little more appropriately on the batch search page. So on the right-hand side, you can see a small frame of all of the lists that we now have available. I believe we are a total of 132 individual chemical lists now. But by putting this prefix in front of the list name, you can see a cluster pattern. So we have a set of endocrine associated lists, a set of EPA lists. We have water lists. So lists of chemicals associated with water, lists of chemicals associated with wikis, etc., etc. Some of these have been added to in the past few months. So now we have things like additives in cigarettes. We finished off the pesticides chemical search subset, curation process that took us many months. Synthetic cannabinoids and psychoactives are there, hair dyes, etc., etc. So these are of interest to scientists working in particular domains. And also we've added the InVitroDB V3 assays have been added to the assay list. And I'm going to show you that. It's easier to show you than to explain in detail. So here we are on the chemicals list. And we have the ability to download the entire list of lists. As I said, it's over 130 now. So if you want one file, one dump of everything that we have described in lists, you would click that and it would download that file. If you want to filter through 132 lists rather than shuttling between pages and you want to find all chemicals that have, for example, the term PFAS in them, you would just simply type that query into the top right-hand corner. And so in this case, you can see what are all the PFAS lists, type in PFAS, and then that is going to give you a specific URL. If you click on the button that says copy filtered lists URL, it provides the URL below it. If you want to share with somebody a set of lists on the dashboard that is done by a filter, you would just send that to them and it would land on that pre-filtered list. This is the list of assays. So similarly to as we've done with chemicals, you can download the list of all assays that have been run. So you can get the Excel file or the tab separated value file. We've also introduced the ability to filter through this entire list of assays based on a single vendor, where you would just select the one vendor of interest, or hold down the shift key and select the vendors of interest. And then that will prune the list that is displayed. And again, now if you want to have a particular search, for example, you want to find everything that has ESR1 in the description, you would put that into the search query and pass that off as a URL. From the assays list page, when you click through on a specific assay, it now loads all the associated chemicals with that list. Now we're into this multiple results display page. This is what I was showing you before. You can click on the modal and it will give you the descriptions about TCPL processing, any citations about that assay, reagents, links to AOPs, etc. We also have an accordion that is now between the assay details and the chemicals display. This is showing you the histograms of log AC50 values across all of the chemicals, and then also the scaled responses. This is interactive, so you can select one or more of the histogram bars, and use the shift key again, select what you wish, and it prunes the list of chemicals below that is described. Here you can also switch to the table mode. Here you would download an Excel file, so you would be able to get this pruned list directly to your desktop. A lot of the work that I've shown in terms of what we're showing there, with all of the interactions with new assay data, chemicals, etc., all of this is depending on the underpinning database, and I'm going to hand over to Katie to describe how all of that came together.
Sure. I hope everyone can hear me. I'm Katie Paul-Friedman, and what I'm going to show you is a lot less glamorous than the dashboard. I want to talk a little bit about how to access the underlying data if you want to interact with these data programmatically within your particular question or workflow. So in this first slide, I'm showing some screenshots that relate to this link that's the downloadable data, really for NCCT as a whole. And here's a screenshot of part of that web page. And in the red box, I zeroed in on InVitroDB version 3.1. That's the ToxCast-related data. We just released this publicly right before the Society of Toxicology meeting earlier this month, so it is brand new. And if you click here, your download that you need, you will get a direct link to Figshare, and if you click on this link that I have in the red box on Figshare, that's where you can download the .sql file, and you can mount this database in your own SQL environment and interact with it. Now, there are a number of reasons why you might want to access these data. Here's another view. This is another way to get to our data. They live on FTP. And here I'm just providing for you as a reference. If you go back to these slides, you can understand what's in these different folders on FTP. So extracting these information from the database, if you know SQL, you can use an SQL interface. However, we actually have developed an R package that probably many of you are familiar with. That's called TCPL, which stands for ToxCast Pipeline. This is available on the CRAN repository. It's also on our US EPA GitHub. You can install it either way. And this R package allows you to interact with our data it's also the same R package that we use to pipeline and curve fit the data. So this is a fully open access workflow for populating that database and then managing and extracting data from that database. We do that predominantly with this package, which is made publicly available. And here I'm showing a screenshot of one of the support documentation articles for this R package. On CRAN, these are typically referred to as vignettes. And the vignettes for TCTL, I think, are critical because what we've done as a center is we've created an entire vocabulary about how we describe these data, store these data, and what even the columns are. So, within the database, we don't use the term AC50. Well, what is the column called, right? So if you want to look up any of these pieces of information, I highly recommend you go to this Introduction and Appendices vignette. These vignettes have been completely rewritten by Mahmoud Choubert and my team. And you can see here in the file structure, we actually have a table that explains every field in the database and every table in the database so that you can get a sense of how we are structuring these information and allow you to interact with them. So additional tables in InVitroDB version 3.1. This is not exhaustive, but these are things I wanted to mention to the broader users so that you're aware of these things being available to you. And these might be reasons why you'd want to pull down the .SQL file and actually interact with the database. So first off, if you're using what we refer to as the cytotoxicity threshold or burst, this is a red line that's typically superimposed over the ToxCast data summary graph. And a lot of people use that in putting their data into context, saying, okay, well, am I seeing a particular bioactivity? Is it in the range of the same concentrations that elicit cytotoxicity? And that's something I hear a lot from our stakeholders. So the cytotoxicity burst information is now stored in a table within the database. Previously, it was in an external table that we didn't release and associated with the manuscript. Now it's actually in the database and should match what's in the dashboard. The EDST21 related models, Tony discussed the availability of these in the dashboard. In the dashboard, you can access the androgen receptor score, the estrogen receptor score, and then two different QSAR models, one for ER, the SERAP model, and then one for AR, the COMPARA model. All of those scores are in separate tables in the database, so you can interact with those programmatically. One that is not in the dashboard but is in the database is the steroidogenesis model, abbreviated here in this underlined table name, high throughput H295R. And I actually have another slide to give you a little bit more detail about that information. But it is in the database, and we hope to, in a future release of the dashboard, have a much enhanced ToxCast models page where people will be able to view and interact with many more of our ToxCast-based models. Tony also mentioned that we have a lot of increased assay annotation. So within the database is a collection of tables, and we have a number of tables that have either been added or significantly updated, and I list them here for your reference. The structured assay descriptions, so these are narrative descriptions of the assay that Tony pointed out. They look like a very short paragraph. Those narrative descriptions have been written predominantly by Keith Hauk and Anita Simcha, and they are stored in the database in these two tables. Again, if you want to pull all of that information programmatically, it is there. The assay lists table is actually, it's a critical table for us in showing which assays are, for instance, EDSP related. But we actually are starting to think about other lists as a way of facilitating research. So if I know a lot of assays are cytotoxicity related, I'd really like to convey that, and we have a separate set of tables, two tables, that now we can store different lists of assays. And my hope for that is in the future, as we see more and more research papers grouping assays in different ways for different research applications, we can store that list, cite the paper, and it'll provide you a way of grabbing the assays that a particular manuscript or research application used in a group together. So that's the aim of those tables. Assay ontology tables were added and populated. These are the ontology tables, and this is also kind of a future application that we've added. What I'd really like to see in the dashboard in the future is if you want to know all the assays that were run in a HepG2 cell, you should be able to query that. Or if you want to know any assay that was a receptor reporter assay and it's based on that technology, or any assay that is based on a luminescent readout or things like that, these are related to the ontology of how we describe the assay technology. And so we've actually added this, and it all is based on the bioassay ontology code. So there's an existing ontology that we're essentially trying to bring in to how we describe our assays. So you can see there's really multiple layers of annotation that we're trying to bring into this process. And then finally, Tony mentioned searching for assays based on annotated gene. Again, Mahmoud Chaber and my team, very tedious and time-consuming work to sit there and hand annotate genes to assay endpoints, but that has been updated a lot. And I think it helps to have it in the database because if you're doing a bioinformatic integration of ToxCast assay data with, Affymetrix data or data that you've pulled out of PubMed of any kind, you might use gene name as an identifier to integrate those data streams. And so that's also provided in tables within the database. And then another addition that didn't quite make it into the dashboard this time around, but I think is important, and I have another slide on it, is there's a new level in InVitroDB. It's very exciting for me. Used to be the ToxCast pipeline went from levels 0 to 6. It now goes to 7. And that final layer in there right now contains uncertainty information related to the curve fit. And I'll go over that a little bit more, but just wanted to provide you the reference here so you're aware of its availability. Okay, so reaching back to steroidogenesis modeling information, on the last page I mentioned the availability of these data. And these are basically from a published paper. First author is Derek Haggard. He's a postdoc in my group. And essentially what we've done is take all of that CTOX, high throughput, H295R screening information, and we've compressed it into a model score. And that's what I'm showing you here on this slide. For an example test chemical, mifepristone, you might know this as RU486. It's the abortifacient drug. It certainly affects steroidogenesis. It's pharmacologically designed to. And what I'm showing here on the left is a radar plot. We currently report 11 different hormones. And in the ToxCast data, that means we have 22 different plots, right? And that's really hard to convey when someone says, well, did mifepristone affect steroidogenesis? And I give them 22 plots. That's often not helpful for having people create a very simple answer to that question. So on the radar chart, we're plotting all 11 hormones, each a spoke on the radar plot. And then you can see with increasing concentration of chemical denoted by increasing intensity of this blue color, we're showing effects. So think about it like a spider web. And if I see an effect within a spoke of that web, it's kind of pulling the effect away from the origin of the circle. So you get this sense that progesterone, abbreviated here prog, and hydroxyprogesterone, there's major effects there. We're really pulling away from the origin. It's disrupting the web from those spokes. And then in the corticosteroid region down here, we see there's an effect where it's shrinking in the web. There's a down effect on those hormones. So this was a way of visually collapsing 11 steroid hormones. Then what we've done is a statistical analysis where in the plot on the right, we're plotting mean Mahalanobis distance, which is similar to Euclidean distance, if you're familiar with that. And so we can report one distance measure per concentration tested. And this is compressing the information from 11 steroid hormones to give you just one metric where I can say, okay, well, the maximum mean Mahalanobis distance here in the blue circle, that surpassed the threshold for positivity, and I can tell you it affected the system of steroid hormones. So that is the model information that's stored. If you want to learn more about it, please visit this publication or send me an email. I'd love to talk to you more about it. I wanted to give you an idea of the organization of data entering InVitroDB through our pipeline. If you're not familiar with it, I don't want to assume that everyone has taken the time to read all of our vignettes. Basically what happens in ToxCast, as you all know, we have a lot of different sources of data. So we get all those different pieces of data from various vendors or sources. We create a customized workflow to get a source file. So we essentially have a baseline file that then gets processed into level 0, which is our first level of just making all of the data from different sources look alike. So the baseline thing I usually need there is I need a concentration, I need to know what was tested, and I need to plot something on the y-axis. So imagine if I could just get every data stream and learn those things about it, then I could start making some decisions with it. So that's what level 0 does. And then we walk through multiple levels of normalization and then curve fitting and then putting some context around the curve fitting. And here's just an example using that steroidogenesis assay as an example where I'm loading all of the different assay source IDs here with TCPL load ASID. So you can see there's a list of vendors or assay sources here. And then I can drill down a little further and say, okay, for CTOX, which is source 8, what are the assay components that were measured? And here you'll see the names of the hormones. And then I can drill down even further and say, what were the endpoints measured? So for any endpoint, right here, it's one hormone, and I want to know, did it go down or did it go up? So I'm plotting it twice. And that's generally the structure of what you see coming out. And this is another way of explaining it graphically, where we take the vendor file, we get a standard raw data format, and then we go through either single concentration or multi-concentration processing, depending on the type of data that it is. And I want to talk a little bit more about these levels highlighted in green. Level 5 is usually, that's the level that people are interested. That's the level where we say something was positive or negative. Because we're taking the curve fit information and asking the question, do we surpass a cutoff for a positive response? And then what was the AC50 of that response? That's happening at level 5. And then level 6 is where we get caution flags, which I hear a lot about from our stakeholders and how to use them and what do they mean. This is really to give more context to the curve fitting that we've performed. And then level 7, as I mentioned, is this new uncertainty estimation level. I wanted to give you a sense of level 7 and how to get more information about that level. This is very much research in process that we're sharing with you in a public way. The MC7 summarizes the uncertainty information for a curve fit. If you see here in the upper right corner, this is a typical plot from the ToxCast pipeline. You may sort of recognize it as having those features. The blue line is showing you a curve fit. The points here are the data points that have been normalized. And then we have this gray line across the top. That's our cutoff for a positive. And then this hashed gray area of the plot is essentially the noise. We're defining the noise by that band. And so on this plot, we can infer an AC50. So this blue vertical line is showing you where the AC50 for that curve fit would fall. But what's really nice about level 7 is now I can tell you the error bar around the AC50. So from what concentration to what concentration might the AC50 plausibly fall if we were to refit these data or maybe lose just 1 point or 2 if we added a little bit of noise in those data? What's a reasonable confidence interval around that AC50? So that information is stored now in the level 7 table. And I've cut and pasted here actually straight out of the vignette, the description of the level 7 table, recognizing that a lot of these things look like jargon. They are jargon. We try to describe them in more simple terms. And if you're really interested in this, I highly recommend reading the appendix on the curve fitting uncertainty. There's also a paper on the R package that we use to calculate this uncertainty. It's publicly available. The paper is Eric Watt and Richard Judson's paper on uncertainty quantification and ToxCast high-throughput screening. And within my group, we have a manuscript in process right now. The lead author is Jason Brown. And this manuscript is essentially going to provide information on how do you filter ToxCast data using level 5, level 6, and level 7 information. What are some practical ways of incorporating these pieces of contextual information around the AC50 for various applications? And I'm really excited about that work. All right. I'm going to give it back to Tony, who's going to talk about what's coming next in the dashboard.
Thank you, Katie. So we've been doing some research work internally and made some good progress on supporting some of the work for mass spectrometry colleagues regarding how to do candidate ranking. So as an example, if you search across the dashboard using some signature from a mass spectrum, it could be a formula, it could be a mass, and you search across the dashboard, you're going to return a set of hits. As an example, if you search for the formula associated with bisphenol A, today in the dashboard out of 875,000 chemicals, I believe you return 310 chemicals. Previously, we've been using metadata such as PubMed, article counts, number of associated data sources, number of products listed in CPDAT. We've been using those for ranking. And that gets you so far. But the actual way to progress is even further is to use the spectral data themselves. So what you'd ideally like to do is take the spectral data associated with a particular chemical that you've detected and use that to search against the dashboard. And what we've been working on is the prediction of the fragmentation for positive ion, negative ion, 3 energy levels for each in LCMS, and then GCMS, electron impact, single energy. So we need to pre-compute all of the spectral data associated with the chemical structures that we have on the dashboard, load them into a database, provide an interface to search the spectral data against, bring back a set of hits, and give you a match factor between the experimental spectrum and all of the pre-predicted spectra. So this is the next level of ranking. We have not built the algorithms ourselves to do this. We've taken advantage of the work coming out of David Wishart's lab at the University of Alberta. This is CFMID, is the open source code that's available. So competitive fragmentation modeling for metabolite identification. That's what it was originally built for, but it can be used certainly to examine these matching between experimental and predicted spectra for things other than metabolites. This is an example of a predicted spectrum for an MS-ready chemical structure. So this would have an associated DTX CID. This is why we've introduced the batch search for CID level, because this is what most mass spectrometrists will be dealing with. This is a mock-up, this is an internal-only access version of the dashboard interface. This is not yet publicly available. This is not even connected to the internal dashboard. It's just a prototype. But what we have here is the ability to input the mass. You put an error on as a ppm error or a Dalton error. You can choose what type of ionization you have done here to measure the spectrum. In this case, we're only inputting single energy spectrum. If you've measured the spectral data at 3 different energies or 2 different energies, you could input both of those. And then you set a filter for matching the peaks between the experimental and the predicted. The result will be a set of scores. So what we have here is, again, single energy. It is measuring the match factor between the experimental and the predicted, and it is rank ordering them from highest to lowest. In this case, there are 38 matches. The highest score gives you, from 0 to 1, it gives you 0.22. The CID level will be linked up to the viewer, and then you will be able to see the experimental spectrum, the predicted spectrum, and the comparison match factor. Every one of those fragments actually has an associated ion, so the interface itself allows you to hover over any of those particular peaks and you will see the individual fragments that have been predicted by CFMID. Work in progress, all of the spectra are already predicted. They're all sitting in a database. The viewer is looking great. We have the prototype interface, and this is presently being tested by our colleagues in NERL. We've also been looking at other ways to perform candidate ranking, and retention time, of course, is very important. We already published on our own retention time predictions that we have for our own models, but we're moving instead to a relative retention time prediction work. This is working with a group in Athens in Europe. They presently have our 800,000 chemical structures and are pushing these through to give us relative retention times. I've reported on this previously. The structure-substructure similarity search capability has been built as a prototype. We have not yet had time to integrate it, but this is to show you that we have this ready. We need to get it prioritized in. This allows you, in this case, to do a substructural search. This could be general functionality, so you can land at the dashboard, perform a search based on a substructure, and find all chemicals containing that substructure. So here's an example. But for mass spec specifically, it could be, if you're looking at a mass spectrum and you know specific substructures, you could add a number of those substructures in as known entities in the chemical, add the formula, and then it would use the combination of substructural fragments and formula to bring up specific chemicals. So this is going to be the chemical forensics aspect of the search. We are having a lot of requests now because the data is so rich, there is so much available. We've done a lot of work to make this available in a way that serves the dashboard, that people now want to integrate this to their own systems. We understand, we support the idea 100%, and we absolutely want to give you access to a rich API and services for programmatic access. Not only for you to use, but it allows us to build our prototypes faster. It allows our colleagues who don't want to tap the dashboard directly, but just the data to do this. We are fully committed to it. Unfortunately, we are, as with many programs, we are resource limited. So we have it on the list. We need to get there. All we can do right now, and this specific slide is from a presentation I gave last week at the PitCon conference, where people on the analytical side definitely want to start hitting the databases, taking advantage of all of the integration work we've done. There are mass spec companies waiting to integrate directly into the dashboard data content so that they can help in doing structural identification. For now, the only path we have forward to help organizations such as this and yourselves is to release the data in a format that you can integrate into your own systems until we have the services and API ready. And the downloads page is where we continue to update data for people to use. Other work in progress and future plans. I am about 3/4 of the way rewriting the manual. We are putting together some training videos. With richness and functionality comes some level of complexity. Even though we're trying to keep it easy to use, training videos will be necessary for you to get the best out of the tool. And there are new chemical lists in preparation for adding to the list page. Commonly, we're adding about a list a week at the moment. Future work, Katie is also responsible for the ToxRefDB database, and we've already outlined what that should look like. So we intend to add some capabilities to view the data in ToxRefDB. We already have real-time predictions using the toxicity estimation software algorithms that were developed by our colleague Todd Martin in Cincinnati at NERML. Those are already real-time predictions, but the opera predictions are not yet integrated for real-time calculation. So that is also very close on the list of things to do. And also, as Katie mentioned, we do want to integrate the 8295R model views. There's some beautiful visualizations there to introduce. And then as we develop more models, we will also make them available via the ToxCast models page. Katie and I are representing the work of many, many people at the center. We work with some incredible colleagues. The NCCT IT development team is led by Jeff Edwards and Jeremy Dunn, and has a group of very hard-working individuals that have pieced together the interface. a lot of the PIs that are listed here, I'll just let you read them. We consult with them on a daily basis to make sure that we are delivering the best and getting the best out of the data and the models. And then we're fortunate enough to work with a group of ORIs and student service contractors. Jason Brown in the room here has done a lot of work with Katie on the curve fitting and a lot of the data rework that's been done. Andrew McCachran, my postdoc, who's unfortunately left now to join Agilent, did a lot of work on the mass spec side. And then Nathaniel, Anita, and Mahmoud have been working very hard with Katie to get the InVitroDB V3 database into a form that we can deliver it through the dashboard. I think that's all the comments from me. Katie, do you have anything to close?
Oh, I'm good.
Got a big smile, so we're glad it's over. We met the hour deadline, and we can answer any questions.
Yeah, feel free to just put those in the chat. And if there's any in the room, feel free. Any estimate when the CSMID predictions might be publicly available, searchable, and all that?
So, as you know, you can use them today. That interface is available to you today internally.
Yeah.
It is really about priorities that are set now for the next release. And to make it public, I don't think would be too much work, but on the list of priorities, it's lower than some of our functions right now.
Sure.
So I would imagine next March, spring release is highly possible. This fall is less likely. But by that time, you'll have proven whether it works well or not.
Absolutely.
Can you give an update as to when the next addition from CPDAT will show up in the dashboard?
So we've been working with Kathy and Kristen. They have got the developers visiting, I think, next week to discuss the delivery of the service API calls against CPDAT. Once that's delivered, then integration should be very possible. Again, priority for release is yet to be defined. We've redirected some of the development team onto another priority project for right now. We have no specific deliverables for August as yet.
Okay.
So it will certainly be available internally sooner than it goes public.
We've got a question in the chat from Max, and he wants to know, what is the reference for pesticide chemical search, and then are they all active ingredients?
So no, they're not all active ingredients. The reference for pesticide chemical search, if you just go to Google and type in EPA pesticide chemical search, it should take you to the EPA database. If you provide your email, then I will make sure to follow up with you directly after this discussion.
And then another question right
So
there.
Brandy has asked, can you comment on the disconnect between the cytotox value on the dashboard and the burst value, which was the previously reported value?
I think that we're pushing out a new release in the next couple of days. Is that
Yeah.
right?
So
That
there's
should amend that and
Yeah.
make it correct.
Yeah, so there was the version that we released had an issue, had a discrepancy. The fix is already in place. The code is already in testing, and I am hoping that it is live by Monday.
Right. So what Brandy's referring to is currently in the dashboard, it's showing the median on the interval for predicting the cytotoxicity burst. And in previous releases, we've always shown the lower bound. And so within the next couple of days, it should also be showing the lower bound. But the values are in the database. The columns are right next to each other. It's easy to see how these things happen. So it should be fixed within a couple of days.
Okay, Nisha is asking, do we have an anticipated release date for the updated ToxRFDB interface? And the answer is no, we don't.
No, we don't have a date for releasing a interface on the dashboard, but actually releasing the ToxRFDB SQL file, the database itself, it's actually in soft release right now. We have a paper in review at a journal. So if you go to EPA's downloadable data webpage that was earlier in the presentation, you can actually go to the animal toxicity data and you can download ToxRFDB version 2.0, which is actually a full database. It's not just 3 spreadsheets like we've released in the past. I think it will be much more usable once our paper is hopefully accepted at a journal, but there is a user guide there for download as well. So, and if you have questions about using the database in your native SQL environment, please shoot me an email.
And then Zheng Yu has asked, could you comment on when the similarity search will be available? Will there be an option for different thresholds? The answer is yes, the ability to set the threshold will be there. The release date, unfortunately, again, we don't have specific release dates for this. The prototype works, it works well. We have to bring it in, spin it up, and integrate it directly into the dashboard, which is not in place yet. So I'm afraid we don't have firm dates for any of this stuff.
Cool. Well, I think that might be all for questions. If you have any further ones, feel free to reach out to any of us, and we'll make sure we find the right person for you. And I just want to say thanks, everyone, again for tuning in to another exciting installment of our Communities of Practice. Goodbye, everybody.